Hello everyone. In this video, we're going to see the topic on linked list. In this presentation, we are going to define what is a linked list and what are all the types of linked list. So in the previous session, we have seen the array implementation of list. So what is the list? List is a collection of elements that could be represented either by the array or by the linked list. So in the array implementation of linked list, we are going to insert the element and delete the element in the sequential order based upon the index value. So in the main, the key concept in that array implementation is the contiguous storage. So the elements are in the adjacent memory. So the random access is very efficient in the array implementation. These are all the things we can see in the we saw in the previous session. Now I explain one scenario. Suppose in your mobile you have a playlist. In the playlist we have a set of songs. Suppose what happens when you want to add a new songs between C and E. You have a list of songs like song A, B, C and E and F. Suppose I want to insert the song D means what is the procedure? What we have to do? So that is a question I will ask. Normally in that array implementation, we have a lot of movement in the particular element. We have to add in the insert in between means we have to shift the elements either towards the left or towards the right. So suppose without moving any data, what we have to do? Yes, we have to implement that concept in the name of linked list. So what is a linked list means? It is a linear data structures. It is a collection of data elements. For the data elements, each element have a two set of nodes. Basic requirement of each node is we have a data part and the next part. So the next part means it point to the address of the next element. So that is the main definition of the linked list. So we have to implement the previous scenario in terms of the linked list. So next, so the linked list, each element have the data part and next part, and that is it is also the collection of elements. You have the head element. That head contains the address of the first element. So that is the structure of the linked list. So the representation of linked list means the linked list is a collection of nodes which can be each node is a content of the one data part and the second is the address part. Suppose you want to that linked list can be used to implement the coefficient. So it can be implement the evaluation of the particular coefficient. So what does that means? We have 3x cos x power 5 minus 4x power 5 plus 5. That is a polynomial representation. So that polynomial can be represented in terms of the linked list. And the 3x power 5. So we have the data part as a 3 and the exponent part is 5. That could be represented in the next data part. Then the pointer point to the 4x square x power 5. That could be the next in the polynomial. It is a collection of the elements. It is a collection of the coefficient and data part that could be represented in terms of the linked list. So, so far we have seen what is the definition of the linked list, how we can represent the linked list. Now we will see what are all the types of the linked list. The linked list are the three types. One is the singly linked list and doubly linked list and circular linked list. In the singly linked list, the each node contain the two parts. One is the data part, other one is the next part. That is a representation of the top representation represented the singly linked list. The final suppose the final data element next part should contain the null or 0 because there is no element in the list. So that is a representation of the singly linked list. Next is the doubly linked list. So in the singly linked list we can move only to the forward position. We can move the For example, we have to traverse the element means we have to move only in the forward positions. So to overcome the particular, for example, in the empathize part, I have shown on the song playlist. Suppose I want to play the song in previous and next song means we can represent in terms of the doubly linked list. So the doubly linked list is a each node contains the three parts. One is the data part and another one is we have the two pointer part. One is the previous, other one is the next. So the each node contain the previous pointer part and data part and next part. So what is the previous mean? It point to the previous element address and next part point to the next element in the particular array. So we can move or we can traverse forward and backward easily in the representation of doubly linked list. Next is the circular linked list. In the circular linked list representation, the last element, consider the last row of representation, and in the singly and doubly, the last element next part contains a null. So that means we could not have any element in the next. In the circular linked list, the representation is the last element point to the first element. So it is in the circular form. So the data part, the last element, it contains the data part and next part contains the address of the first element. So that is the representation of the circular linked list. So this is the singly linked list representation that list contains the three elements. One is a 12, 20 and 28. So the 20 next element is 28 and previous is the 12. So this is the representation of the singly linked list. Next is a doubly linked list. As we said, as I said that it contains the three parts. One is the two pointer part, one data part. On the data pointer part, it is a previous and next. That is a memory representation of the doubly linked list. Is it contains the each node contains the three elements. Next is a circular linked list. In the circular linked list, the last node of the list contains a pointer to the first element. So that is a representation shows that the list contains a 1, 2, 3. The 3 next part contains the address of the 1. For all the linked list, we have the head structure. That head node contains the only the address field that points to the address of the first element. So through the head only we can traverse and we can find the list in the particular memory. So in the circular linked list representation, for example, in the last node 8, that is contains the address of 1. Okay, so we have that in the memory representation 1, 2, 3, 4, 5 is the index. So for example, it shows the address value. So the last element contains the address of the 1. So that is a representation of the circular linked list. So let us summarize. Let me to summarize. So this is the in this presentation we have seen what is a linked list and what is the need of linked list and what are all the types of linked list. So this is the one set of assignment. For example, the list contains the 10, 20, 30 means you want to insert 15 means after 10. So what we have to do? We have to traverse the particular element. For example, the 15 should be inserted before 10. So we have to move towards 10. And after 10, we have to insert means the 10 next part should contains the 15 element address. Then 15 next part should contains the 20th element address. That is the way we can insert. Thank you.